Okay, so for peak hour, the supply is lower than demand. At this time, we will actually increase the price and also increase the wage. When we increase the wage to drivers, there will be more drivers available on the street providing service. And when we increase the price, there will be less demand. For example, if the price is $15 to go home, you will take a taxi. When it reach to 20, 25, you probably give up and take MRT. So we will reserve the taxis for those people who really want to pay and really need it. Eventually, when we increase the supply and decrease the demand, at some point the supply will be equal to demand, and then we have a system equilibrium. That's the thing we want, right? So remember, we don't want the supply to be greater than demand or to be less than demand. We just want the supply to be equal to demand. That's all the goals for any economical system. Okay. On the other hand, for off-peak time, we have supply greater than demand. At this time, we will lower the price and also lower the wage. When we lower the wage, there'll be less drivers available. Some driver will give up, say, hey, the price now is not that attractive. Let me just rest a little bit. Okay. So, and also when we reduce the price, there'll be more riders, okay, more customers asking for cars. Like normally it will be $10 for you to go to school, now it becomes 5 or 6. It's only a little bit higher than MRT, then you might also want to take it, right? So when we lower the supply and increase the demand, at some point we will also have supply equal to demand. That's the goal of the system. So the surge pricing is actually a dynamic to match demand and supply to have the equilibrium. Okay. So let's say a little bit more here. So the utility of drivers and riders. Okay, so for the utility of drivers and riders, well, first of all, it depends on money, right? How much is it? For drivers, we need to look at, if I drive now, how much can I earn? And for riders, if I take a ride now, how much I need to pay? So that's the wage and the fare. Okay. Also, it depends on the matching speed, right? So which means the time it takes to get a rider or driver, right? So nobody wants to wait for a taxi for an hour. Let's say if the taxi is only $5, but you need to wait for an hour, I don't think anybody can want to take it. On the other hand, okay, so even if the price is very high, let's say if I drive for 10 kilo, I earn 100, but I have to wait for like a few hours to get a passenger, then it's not good for the drivers, right? So actually this altogether to set the optimal price, it becomes a queuing game model. It will be very complicated. We won't go to detail, but that's the idea. So how Uber set the price, we need to consider two things. One is the money value, right? The wage and the price. The other one is the matching speed. Add these two together, you need to do some prediction, put into model, and find for the optimal price to set. Okay. Then the next thing to talk about is actually the disadvantage of surge pricing. Okay, for every new thing, there are good things and there are bad things. The good thing for surge pricing is this is a very good mechanism to match demand and supply. But on the other hand, there are disadvantages of this. So the most important disadvantage of surge pricing is that the drivers can go up to cause surge. So examples like this happens a lot in many countries, including in the US. So the drivers know that, okay, so if there are less drivers available, the system say the demand is greater than supply, they will increase price, and increase the price. So what are they going to do? So okay, so let me tell you briefly what they do for surge pricing. So for surge pricing, it's not like it's not fixed. So it's not like taxi. Okay, after 7 p.m. it become double of the price. For Uber or Grab, the method they use is different. It's actually some kind of a continuous increasing method. So for example, now this is the basic price, and then the system found that currently for some area there are more demand than supply. Then they gradually increase the price, okay, and the wage. So every time they increase like $0.50 or $1, and say what is the outcome. If they see lots of new drivers coming to the picture and some passengers drop, then they may increase a little bit more and a little bit. So they each time they only increase like $1 or something and see the outcome. And if we can hit the equilibrium, which means demand equal to supply, then we stop. If we cannot reach demand equal to supply, then we keep on increasing the price. So, well, if everybody is rational and everybody is like doing legal thing, so the drivers cannot talk to each other and they're not strategic. What happens like this? So for now, let's say the price is whatever $10, for example, for the trip. Okay, then there are less drivers and more riders. Then we increase the price to be 11 or 12. Whenever we increase a little bit of the price or the wage, there'll be more drivers, more drivers. For example, every time we increase $1, there'll be 100 more drivers becoming available. Okay, so after a while, we increase $5, there'll be 500 more drivers. Then that's it. That's all we need. We stop. However, what drivers can do is that when they see the system starts to increase the wage, instead of providing the service, they talk to each other, say, "Hey, let's don't do it. Let's wait together. If nobody is answering the request, then the system has to increase, increase, increase. Let's wait for the system to increase to like 20, 30, and then we start to work." That's what we call by drivers gone up to cost surge. Okay, so this happens a lot, also happens in Singapore for a few times, okay? So when you see that the price is always 40, 50, it's not because system error. Sometimes system error, but most of the time it's because of the strategic behaviors of the drivers. In fact, this is actually not a smart move of the drivers, okay? So why? Because the passengers are not stupid, right? So when the price becomes like 20, 30, 40, not everybody gonna still take a taxi. Lots of us gonna give up, right? To find outside options. So even so, sometimes it happens a lot in the U.S. So it's actually very important in Seattle. Every time for the night of July the 4th, which is a national day, something. After that, I mean, after fireworks, everybody want to get a car and go home. Then the drivers gonna go up and cost the surge, or they increase the price to be, I think the record is 15 or 20 times of the normal price. Then they're happy. They want to drive. However, at that time, there's no more passenger. Even the price is very high. So if you can get a passenger, you earn $200 immediately. However, you cannot get a passenger, so that's zero, right? So you see what I'm saying? So it's actually not a smart move for the drivers. So there's a lot of education videos to let the drivers stop doing that. Uh, so from the passenger's point of view, it's good to have outside options. For example, traditional taxi. So there's always a dilemma people talk about. Now Uber and Grab are so good and they're providing much better service. And as we mentioned, since the supply and the demand are dynamic, there's less waste, less emission, less congestion. Should we just have the whole city served by Uber or Grab and no traditional taxi? Well, it's actually not a good case, because if we do not have an outside option, then it's monopoly. Then the price will become very high, and the drivers can be very strategic. Okay, that's also why now the price is higher than in the past when we have both Uber and Grab competing.